Good morning, colleagues. Today we are going to perform exercise 3.1 from the Seiko Electrical Circuits Fundamentals book, and we continue solving the exercises until completing the book's solution. In this exercise we are asked to determine the zero voltage that is at this point and the power of each of the resistors. Now, what I always do is a visual analysis of where the currents can circulate and then I add the names. But if I see that this voltage source is 36 volts, the polarity more or less, I say that the current comes through here until it reaches this point. Where it reaches this point, it has to take a path to other sides. The first one that comes to mind is for this one, since it is pointing to ground, and the second is going to be for the resistance of 4, but that resistance is 4. Let's look at the source of tension. We observe that this source of tension has the polarity lower and less high, which indicates that the greatest force is directed towards it. So, through that visual analysis that I am doing, I say that the current goes in this direction. Now there I give a name to the currents, and I am going to call this the current, and one is going to call it 42 to 43, and I make a the RCK in this node. I say that the current that enters the point of the Y1 is going to be equal to the currents that leave the Y2 plus the Y3. Well, the current one comes from here. It is a difference between voltage 36. Since the current has this direction, it is assumed that 36 volts greater than 0 is A. It is assumed by the address that we ourselves read. I say 36 volts minus 0 over 1. This is equivalent to the current, and 1 volt voltage over resistance is the current equal to N2, and the N2 which comes over here 0 over 2 ohms plus the .43. Let's know that the sub-zero voltage generates a force to the right and the voltage of 8 volts. Instead of exerting an opposite force, it is exerting force towards the same side. So, I think it's 0 plus 12 volts over 4. Well, then here I have to. Well, I'm going to divide. This would be 36. 3686 sub 0 equals AB 20 over 2. Plus 0 over 4. Plus 12 divided into 4 sectors. Okay, so I have to clear the variables to pass this one here to the other side of the equal. I would then be left with 0 plus 0 over 2 0. About 4. This equals 80. Leave it still there minus. This is plus 3. I'm going to pass it to the other side the same. Therefore it would be minus 3. Okay. So if I operate this, 1 more, 1/2 more plus 1/4. This will be like 7/4 of sub-zero equal to 33. Well, then after 0, and I'll be left with that. To be equal to 18,857 volts. Okay, I've got the voltage at this point. Now it asks me for the power dissipated in each of the resistors. Well, then we can determine power as voltage times current. Or we can also determine it as squared by resistance, or voltage squared over resistance. Now, since I have tensions, because this equation is easier for me, one uses the one that is easiest, the one that is most facilitated. The one that one avoids is going to be one more step. So I'm going to move here. Well, then we are saying that we can calculate the power this way as a voltage times current in the resistance or the current through the resistance squared times the resistance or voltage squared over the resistance. Okay, so the power in the resistance of 1 ohm, I'm going to say A, the voltage of 36 volts. I'm going to mark here 36 volts minus 0 this voltage minus this voltage. The tension in a man's resistance. This is V, which would be the one we are going to use there. Therefore, that expression I am going to square over the resistance which is 1. So this is going to be equal to 36 to 0. There are 18,857. This squared over 1. Therefore the first power gives me 293.88 watts. Okay, now I want to determine the power across the 2 ohm resistor. The resist we are 2 men. This is 1. They are 2 men. It's going to be equal to the voltage. The resistance of men. 0 the voltage between this point and this point would be 0. Zero squared over men's stamina is 2. Note that here 0 would be over 2. Equal to 18,857 squared over 2 plus 110,177,107. And finally, the power in the 4 ohm resistor. The 4 ohms. It's going to be equal. We observe here that it would be the sub-zero voltage, but instead of being less it would be more due to the polarity of the source. The sub-zero 18,857 plus the 12 0, which would be 18.85712 plus 12 squared over the 4 ohms of the resistance. And that gives me 238 watts now.